Hey, we are live. You have reached Saturday Science Chats. Yes, indeed. Yes, indeed. You have reached Saturday Science Chats. The good news is we'll be doing pretty much getting back onto a weekly schedule. So I want to thank everybody. But this is sponsored by the John Chappell Natural Philosophy Society and Dissident Science. And today we're going to be having a panel discussion, meaning you can come in and discuss with us what do we keep and what do we throw away in science. There's quite a lot that a lot of us who've been around many decades who are critical thinkers would love to throw away and do throw away, actually. You can throw away anything you want, it's up to you. But do make sure you subscribe and like to this channel, whatever you're watching it, whether you're on Facebook, whether you're on YouTube, whether you're a Dissident Science channel, or you are watching it through the CMPS channel, which we're up to over 1,100. So I want to thank everybody for subscribing. But don't forget, it just takes a second to hit the like button. That helps us in the algorithms and it helps us get more people in this direction because there's nothing like this on YouTube. I know it really isn't. It's pretty amazing since everybody's got a YouTube channel now, everybody. But you're never going to find anything like this except for here and all the people who support this, which is great. In fact, we are going to a new format and it's going to be great here. Every other Saturday, I will be here with David and Dissident Science and the CMPS on more general topics like we have today, sort of to get a more broad interest in talking about things. And then on the other Saturdays, the CMPS will be broadcasting. It won't be broadcast on Dissident Science, but it will be on the CMPS channel. And a really great in-depth series of topics for people who really want to dive into some of the topics for relativity or time or electromagnetism, etc. And so we will be doing these every other week. One week I'll be hosting, another week we'll have some other hosts talking about much more specific in-depth topics. And coming up is going to be something on Unicode. I don't have exactly the exact topic, but it's coming up next week. Harry Ricker has been doing some talks. You do want to check a number of these talks. These people were talking already in our CNPS organization on the YouTube channel Nick of Time. That's Nick of Time is one of our CMPS members, and you can go back and watch this. Just search for Harry Ricker and Nick of Time, and you'll get some of his talks already. Very, very insightful talks. I always enjoy Harry. Harry is one of my favorite cantankerous scientists. He's also a great writer. You should check out beyondmainstream.org. Beyondmainstream.org. He's got a bunch of articles there. Lots of people, I don't know, for up to 100,000 reads on that site. But amazing article. Very, very good writer. Not just a person writing about their work, but I mean, very insightful, very entertaining writer. And he also is a critical thinker and really has some really great talks coming up, and one of coming up next week. So you don't want to miss that next week. Same time, same channel here. And then after that, we will have our first Lifetime Achievement Award. We're going to be actually giving out these a lot more because we have so many people deserving and we don't want to lose them. They're a lot of them elderly octogenarians, but the first Lifetime Achievement Award will be on December 3rd with Nick Percival. We will have others that will follow, quite a few, because we in the organization have to really start to recognize these amazing minds that in the future will become, perhaps household names for their work. But you don't want to miss that. And we're going to talk with Nick. He's got an absolutely fascinating life and his work. And I'm really looking forward to that conversation. We're going to talk about his experiment he did with the Einstein Institute or something like that in Germany, where they had to answer your questions. So he sent them some pretty provocative questions. Hopefully, I think he's got some work on that, but we're going to talk about that. It's just going to be a discussion for a couple hours. You can ask him questions, but I'm sure we can fill way more than that time. And just a super interesting person. And of course, you can visit our websites. Naturalphilosophy.org is our community. I've been cleaning that up. We've had, everywhere it's getting spam. So got it cleaned up, keeping that cleaned up there. Go in and you can discuss really great discussions you can follow in there. Just register there and join in. If you've not been around critical thinkers or dissident science thinkers, you may want to check out our beyondmainstream.org website. And that's like it is an online magazine. It's totally readable by anybody and people who like science. So you don't have to be technically savvy to read that. There's a lot of just general articles. Harry Ricker has articles there. Glenn Borkert has articles there. I have myself, I wrote a bunch of articles as well. Very interesting. So you want to check that out. And then, of course, we have a Wikipedia, Wiktionary, it is Wiktionary software, but it's wiki.naturalphilosophy.org. And you'll find over 10,000 pages of people who are critical thinkers working outside the mainstream. You can become a member to support this. We have our regular memberships, which are monthly and annual. Of course, we take donations as well. You can go to membership.naturalphilosophy.org. And I do want to thank all of our members. We have monthly members from $5 all the way up. We do have annual memberships, so we have something to fit all of your budgets. But of course, right now, at the end of the year, we're having our fundraising drive. We're 1/3 of the way to our goal. I want to thank so many people for already contributing. Why do we need it? Well, there's a lot of reasons, but you can go to fund.naturalphilosophy.org and donate. We have our memberships, but they don't cover our expenses. Those expenses are important, so our memberships don't pay all of our annual expenses. We need to constantly solicit individual donors, so we're trying to now consolidate into a one-time fundraiser, and I do want to thank the people who've already contributed. We do need some breathing room financially. We're going to be giving out the Lifetime Achievements Awards. Those are certificates and frames, got to be sent. It's also pretty stressful for us to constantly be living on the edge with us financially, and if we can at least get people to contribute. And I do want to again thank all the contributors. I see some here in the joining today. Greatly appreciated and greatly needed. And of course, no one gets paid for this. All the money goes toward the organization. And our biggest money makers in the past were our annual proceedings and our in-person conferences. In-person conferences just don't exist anymore. And because people got used to COVID and doing it online, and we kind of do a conference almost presentation every week. We do need to get back to the annual proceedings. That does bring us some money because people do have to pay to get into that per page. And that's where we got our money before. But again, those kinds of things are not happening as much. What this provides for you is a community-friendly website that's really nice. That's allows you to talk about pretty much anything. You can criticize anything as long as you're polite and nice and civil and talking, not gibberish, but talking real critical thinking. We recognize all kinds of things, criticisms of mainstream science. We also recognize people who are trying to come up with new models. So if you're a person with new ideas and want to discuss with other like minds who are critical thinkers, we'd have that a really friendly website for that. It's kind of like Buddy Boss on web, which again, we pay for all these things. And that allows people to do discussions just like Facebook. We do have our weekly and monthly live streaming discussions on YouTube and Facebook using StreamYard, which we're using right now. And we do have a latex for publishing, which costs us a monthly fee. Not too much, but it's for Overleaf, which allows us to publish books and papers. We've published a number of books already via our system. And we do have email blasts out to people, almost 1,000 people we send every week. And that, of course, is also not free. Nothing's free anymore. And our Beyond Mainstream website is really great for critical thinking, an online magazine. If you do want to write anything or add to our Natural Philosophy Wiki, you are free to do so. And just contact me, David at naturalphilosophy.org. I'm sorry, .com is too expensive. But .org. And you can be added, or you can even write some articles about even your work. That's the idea here. So, just to give you an idea of their expenses, here are some: MailChimp, Overleaf, server security. That's not a monthly expense. I got to fix that, folks. It's actually yearly. You can see our server. You think that's a lot. It's not a lot when you look at it per month, and it is a full server. It's not just a website hosting. It is a full blast, full server. And these are our subscriptions. Oh yeah, your security's down here, so this can be gone. These are really our 2 monthly things. Membership press, that allows us to do memberships. Even having memberships costs us to costs us to do collect memberships. So all that, and StreamYard, of course, is actually quite reasonable, and our domains and our certificates, so that people come to our websites and they are certificately sound. But what we're going to do is we're going to talk today about we're going to have a panel discussion on what do we keep and what do we throw away. Of course, all of you who are dissident scientists, but really critical thinkers, we have basically criticized every aspect of physics, cosmology, and even mathematics. And it's not just because we just want to come up with some new thing and throw it away and we don't know what we're talking about. No, this is based on many, many decades of work, very brilliant people. And I want to just thank, first of all, the community that I have been a part of since 1996. In the early 90s, I was got to know a dissident scientist, and it is an honor to be associated with all these people. Now, if you do want to sign up or add to our fundraiser, to donate to our fundraiser, you can see that down there with fundraiser, fund.naturalphilosophy.org. So you can get that. And also, I am going to put up here, if you want to come and chat with us live, you can. All you have to do is go to live.naturalphilosophy.org, and you can come in here to the green room, as I call it, and discuss with me on air. And I will be putting up comments, so keep those comments going. And I'll try to put those things up there if you have any comments to put on the air. So anyways, let's take a look at all the things that we have many people who want to throw away. I mean, actually just say a lot of, I can't, everything on this page is something that I know great scientists, great thinkers, very intelligent people, very rational people who have at one time or another said these aspects of science are wrong. It's not even that they're some of them are even close. Of course, the real number system, that should be not plural, real number system is flawed. I mean, I've got a degree in mathematics, and I'll be the first to tell you that. But I'm still amazed that we have so many areas that have been looked at in the 20th century. Most of it's come from the 20th century that we really have questioned. And I think Einstein kind of started a bad precedent. Einstein came along and kind of put the way I describe it to people, he came along and dictated what the universe should be. And instead of the idea that you're going to try to observe the universe, look at it, and come up with some conclusions and some models and ideas or equations or whatever it is, and go from there, Einstein came along, maybe he didn't claim to have these were based on work before him, although there's a lot of dispute on that. But he basically came along and said, you can't go faster than the speed of light. And, all physics is the same in all reference frames. And the speed of light is constant. All of these things, and the truth of the matter is, he actually did talk about light speed not being constant. But regardless, he kind of came to the universe and said, this is the way the universe has to work. And that's why you get all these kind of really weird things like time would slow down and length contracts and mass increases as you get closer to the speed of light. It's kind of dumb to imagine that we just as a scientist will tell the universe what it's supposed to do and then assume and then try to show for our physics to agree with relativity, it's got to do very strange things. The second thing that I think got us in trouble in the 20th century in general, and this is with everything, not just science, but in art, music, is that we got to the point as the human race where we thought we could accept almost anything, any proposal. We could accept, Einstein started out by, time, people are doing the calculations. Well, time should be slowing down. Uh, time, length will contract and mass should increase. And people go, oh, wow, that's pretty cool. Or, gravity bends light. And then you get into the quantum mechanical world where people think, their things are going to be in two places at once. You've got, what is it? Spooky action at a distance where things are supposedly, knows the state of something else instantaneously. Whereas I think almost everybody in our group doesn't believe in anything instantaneous. You have all these things that in the 20th century in science were put out there, and we just started accepting it. The idea, the most used phrase today, because is that the universe is way stranger than we think, that our brains can't really understand it because, quantum mechanics is a good example. Whereas I have a meme from our webs that I put up there that says, it's not that the universe is crazy and illogical. It's our theories that are that way. The other thing that happened in the 20th century wasn't just science, was music and art. I mean, you had in the early 20th century, you had artists who were more philosophers who would put a urinal. Duchamp was very famous for his act of taking a urinal and putting it and entering it into an art show. So people started to, look at art completely different. I mean, I've seen this meme so many places where you see this old couple looking at a fire extinguisher on the wall in a modern museum, art museum, thinking it's a part of the exhibit. Yeah, I mean, we became in the 20th century muscle bound, as they say, to accept almost anything thrown at us. That things in the universe could be really strange. John Cage, if you're many scientists in our group are very, science and music go together, and so I love music theory, and I play the piano. A lot of us do scientists do music, and John Cage wrote some music for a string quartet where they sit around for 4 minutes 23 seconds with the sheet music in front of them and don't play anything, and that is music. So we have come to accept anything and everything in science, art, music, life, that it's all valid, and that all these crazy ideas are actually that's the way the world works. That's the way the universe works. Yet when you take the time, what I would say to you, if you're a person who just kind of stumbled upon this channel and you're saying to yourself, how could all these things be wrong when all these universities are teaching it everywhere? There's a couple things about that before we get into each one of these and we talk about them and have some discussion, hopefully with some of the people. Again, come in live.netphilosophy.org. And let me see here. Einstein I'm going to put some of these comments up here. But the idea is that when people come here and they don't understand why so many people are teaching this and why people assume that this is all correct and they hear it all the time. The number of people who are involved in every one of these topics you see here, every one of them, is a minuscule part of the critical human mind and scientists. The number of people that go into theoretical physics and cosmology and are on the bleeding edge of these things are extremely small. And if you talk to the average scientist and engineer and you talk to them about strings that are one-dimensional strings or the Higgs boson or quantum mechanics, spooky action at a distance, or dark matter or space-time, all of these things, people, it's not a general consensus. Most people are extremely skeptical of these things. Now, I know a lot of even our dissonant people may not agree with that, but that it is true. I mean, I've seen it firsthand in 1999 when Dr. Karazani was asked to talk at a amateur astronomy club on Long Island, which was frequented by Einstein. We That was 99, and we were having discussions with those people about how redshift was simply not real. I mean, simply not what we think it is by moving. And the things were moving away. And so that they were talking about the redshift between galaxies. They weren't sure exactly what that was, but they were looking at redshift as a different phenomenon other than the idea that the universe was expanding. And if you talk to the average physicist, they go, I have the saying, they say, wake me up when you have something real. Anyways, if you've just come to this channel or you just stumble upon this, what these topics represent and why people are disputing them is because they sat back with no pressure from their jobs, no pressure from their peers, and were able to say to themselves, I'm going to look at these theories for what they are using a critical thinking mind and find out whether or not these things really make sense. Because when you look at these, there's very few of these that a person would not question right out of the gate. Relativity, can't go faster than the speed of light. That's one a big one. People hate that idea. The Big Bang, everything exploded out of this little point in space. It does, in space at time it expands. Black holes, the idea of you have this singularity in the middle of it, nothing can escape it. Oh, now things can escape from it. Quantum mechanics. We have Eric Reiter, who's in the green room, who's done a lot of presentations on how quantum mechanics is just the problem is the interpretation of what they're seeing is simply wrong. Space-time is mathematics. It has nothing to do with real physicality. What is that? Space is nothing. Time is a concept. It's not something. Movement is real. Time isn't. Dark matter. I mean, that just screams of a kludge. Quarks, the name, the idea was we had atoms, and atoms were going to be made of the subatomic particles were going to be made of even smaller particles, and they're going to be one particle. And there were quarks, there were 6, then there were 9, then there were 6 again. And they have the most strange packages. They're arbitrary packages with arbitrary attributes. Neutrinos, if you spend the time to look at neutrinos, you're just going to, if you spend the time on their arguments on any of these things, saying that these things, looking at their arguments go take a look at it. Take a look at the people who have criticized that. Higgs boson. Same thing. Read the Higgs fake. Strings, plate tectonics. That's one that people do talk about. But then when you listen, one of the things that plate tectonics that people don't necessarily think about, don't necessarily remember, is plate tectonics has this thing called Pangea, right? All the land was on one side of the Earth. Now there's the reason we have that, if you're a critical thinker and you've looked into other examples like expansion tectonics, well, what you say is, how could they and why would they all be on one side? It doesn't make sense. In fact, if you do calculations, the physics of a rotating planet, if you have a planet with with land on that side, it's going to, by rotation alone, create another island on the other side to balance it out. You can't have this imbalance on the planet without having an effect of the oceans. And so you have that, and the only reason the reason we know that Pangea is what is Neil Adams, the late Neil Adams says it's a knee-jerk reaction to us being able to see very clearly that South America and Africa fit together. Well, it turns out that they all fit together. So plate tectonics, we even when you think about it, when you're taught in school, it's all on one side. I think there's every person kind of thinks that. That's really weird. Why? The real number system. Oh no, everybody believes that's true too. No. Plate tectonics. Do I have it? Yeah, I spelled it wrong. Thank you, Michael. I spelled it wrong. But real number system. We think of to ourselves. Oh, Dave. Everyone believes the real number system. I've got a Bachelor of Science in mathematics from a university myself. I love math. The real number system's got real problems. The square root of -1 is this biggest problem. So there are better number systems. Look at Peter, my goodness, infinitesimals and the number. I've got his book over here. Peter, darn it. Anyways, very good books on mathematics. Peter Erickson, infinitesimals and the veritable number system. So check that out. Also, you have Kirkswild. Can't remember his. I think it's James. He has a new number system as well. I'm blanking out on that. But anyways, all of these things, strings, one dimensional. Come on. I mean, that doesn't make any sense. Anyways, these are all things that we have disputed in this group. And so let's go on here. Here's disputing the status quo. Eric Lerner wrote The Big Bang Never Happened. Sabina Hossenfelder, I guess her name is Sabina, I was told by somebody when I talked about her. She wrote the book Lost in Math in 2017. She left the Large Hadron Collider and said basically people are lost in the mathematics and not the physics. I was hoping she would be more dissident when she got out. She then turned into a science evangelist, is now turned into a person who just talks about science. Doing very well on YouTube, but she, unfortunately, I think she lost... she sold out, no offense, she has sold out to popularity and making a living, which so many people will do. And that's why a lot of the things like in science continue, because you study relativity or you study the Big Bang, you then become a professor, you teach about it, you generate look at that, wrong language, more dissertations, and then just keep perpetuating. Of course, this is a must read by everybody, The Higgs Fake. Every person who loves science should read this. Alexander Unsker, who has a doctoral degree he's from Germany. He has his own website. He talks about the non-constancy of the speed of light. That light is not it's a constant speed. He's been doing a lot of stuff. Check out the Mach-In on YouTube. Really great. Sabini, you're just going to get. She's turning into another. Neil deGrasse Tyson, which I call science evangelists, not real true critical thinkers anymore. She does come out once in a while. She kind of touches on it, but I'm kind of disappointed in that. Of course, Not Even Wrong by Peter Voigt, which talks about the string theory. The folks, I saw the string theory people being interviewed in the 1990s, and they were sick. They said, "What's your biggest fear?" He goes, well, that people actually treat that as real. He says it was a mathematical exercise, never meant to be real. Now you got Neil deGrasse Tyson saying string theory will save relativity, which general relativity, which is wrong at the singularity of a black hole. Gosh darn it. How much garbage can you put on top of garbage, right? But anyways, that's another one. How Einstein got relativity wrong. We have over 2,000 books and papers that have been written on how Einstein's wrong. GPS, everybody says uses relativity. It does not. In fact, if you look at GPS, it contradicts relativity. And we know that for a fact because one of our late members of CMPS, Ron Hatch had over 30 patents in GPS. And in the statement he had in my film, Einstein Wrong, I asked him, I said, what can you say? He says, GPS doesn't support relativity. It shows the flaws in relativity. Plate tectonics, we have people who are disputing it but have better models beyond plate tectonics. Got to read. If you love geology and plate tectonics or like that whole idea, that's a must read. It's for free. You can read it now for free. And of course, you have now people also looking at black holes, the Big Bang. The Webb telescope got out there, and then the Big Bang had a lot of problems because it's always been a problem. Every time we get a new telescope, we see further in the universe. It gets older for some reason, but we still try to, with inflation and all these games we want to play, we don't want to admit that the universe may be actually eternal. So there's a lot of people out there who are looking at the status quo. We do have replacements. People do have replacements for the Big Bang, an eternal, infinite universe. We also have replacements for the current models out there. There are ether models, particle models, lattice models. We have people talking about 100% Newtonian universe. I know people I can see in the chat that don't believe that. It can be done because we have at least two models, three models that are doing it. Well, two models in a very detailed way, including the quantum level of the universe. Jeff Yee, go look at his Newtonian models for the atom, where he's getting SPDF orbitals with Newtonian mechanics. So is it possible? Yes. So you can say it isn't. You can say it all day long. It isn't, it isn't, it isn't, or I don't believe. But we have many people with today's models that are showing, even in the subatomic world, that everything is Newtonian. You don't have all these weird forces. There's also the electric universe people out there who are looking to look at the universe, that there's much more things going on the electric side of it than gravitational. A lot of people think gravitational part of the electric. That's one theory. All these things are valid. Expansion tectonics, of course, is, in my opinion, and many people's opinion, I mean, not even comparable to plate tectonics. The evidence for expansion tectonics, in my opinion, is if there's anything that's a new area in science that I would bet everything, my house and everything on that's correct, is expansion tectonics. And of course, we have new mathematical systems, I should put there. So anyways, that's kind of my talk, the beginning here of to get things kind of rolling with this. But going back to the slide here, is there anything we want to keep here that people think that want to come on perhaps, and you can come on again. You can go to live.naturalphilosophy.org. If you again like this channel, please click the like button. If you're just sitting there, just put your finger there or use your mouse and click on it. It's really important. I'm going to go through the chat here, but we have people in the green room. So if you want to come on, go to your browser and type live.naturalphilosophy.org, and you can come in and speak with me. You can do that on your phone, on your tablet. So please wave to me if you are in the green room, if you want to come on board and talk and always help me out. I always do appreciate that. So hello, Nick, you are muted. Let's get you unmuted.
Yeah.
Yeah, first of all, before you start talking, I want to congratulate you on being, how do you say, chosen as a Lifetime Achievement Award for your work. Way overdue. I do apologize from our standpoint of CMPS. And we look forward to chatting with you, because I can talk with you for a long time. You got so many interests. After a few decades, you have a few stories. Isn't that correct?
That's right. As long as the memory holds up.
Oh, yeah, that's you. My dad say the same thing. And I was talking with my dad, who's an octogenarian, the other day, and people accusing people of old age of losing their memory. It's really short-term memory. I talk when he says, oh, yeah, my mom said when I came home from the hospital, that's what he was saying. I'm going, okay, Dad, you're ruining all this idea that octogenarians don't, are losing their minds. So, anyways, congratulations. Very, very well deserved. And I look forward to our presentation and talk with you on that.
Thank you very much. But this does not mean that I'm going to be sent out to pasture.
Oh,
Uh,
please, no, no. No, absolutely not. It just means that you're going to be recognized as you should be. So, it's really, I was thinking, because coming up with topics that are kind of general topics that are kind of
yeah.
interesting, and it really is, because if you look at our group, we got people in the chat saying, Newtonian physics should be thrown away, right? And I'm not, and I don't argue that it should or shouldn't be. It's interesting that even in the dissident world, how many people, if I look at all these things that we have up there, right? Relativity, Big Bang. Obviously, you talk about relativity, but all of these, I'm really of the opinion that all of these are in big trouble. All of them, in my opinion. So you who have worked on it for a long time, worked on time, looking at just time and relativity. What's your opinion about? I mean, because we talked about that specifically with you, but what's your opinion about in general all of these areas? Because it is a big. I mean, we're not looking at small portions of theoretical physics and cosmology. We're looking at the whole darn thing in reality. I mean, what's your take on that? Because you've been, even though you've been in one area, you're a big thinker. What's your take that you got somebody that you were talking with and you put this list up for them and they're saying, okay, Nick, uh,
Uh-huh.
you say that these are all up for grabs and maybe most of them or maybe all of them are going to have to be replaced with something better. I mean, why is that? And what do you think about that? What's your take on all this?
Okay. I'm going to first make kind of a pro. I'm hearing an echo.
No, you're okay on our side. You're good.
Okay. Uh, for people who are turning in and haven't gotten a background on dissonant thinking or critical thinking, they may make a couple of quick points. Like the number system is okay in something like accounting, where you can have negative numbers representing a person's debt.
Oh,
But
wait,
in
wait, wait a minute,
terms
wait a
of
minute, wait a minute,
physics,
wait a minute. I know what's wrong. Okay, go
oh,
ahead. I got it. I fixed it. Okay,
okay.
sorry about that. Start over again there. I'm sorry.
Okay, so if someone sees that list for the first time, remember this is a list of 12 broad areas, so you can't think of it totally as white and black. So I don't want someone to just turn off their listening just because they have a different perspective or whatever. Like the number system, uh, that's okay for some aspects, say, of accounting, where negative numbers represent debt. But in terms of physics, it really isn't the right number system. Another example is quantum mechanics. Certainly, technology has made tremendous advantages in the 20th and 21st centuries here. Um, so, quantum mechanics isn't, which is the basis for many of those advances. What I think of as quantum mechanics is sort of an approximation because it's really built on a statistical model, but it doesn't really have a good physics model under it, which leads me to another point. Actually, that reminds me of currently accepted thermodynamics, which is the same thing. It's really a statistical model without it ever telling you what it's wrong, and it's compounded by making a false assumption. Kent Mayhew, who has contributed many articles to the CNPS, has a new and improved thermodynamics. That's a major area of physics that needs to be done, totally redone. And for one thing, it has people going off in the wrong direction on climate change because CO2 is not the villain. What happens is uh, all activity has lost energy. But where does that lost energy go? Classical thermodynamics does not account for that. It's just gone, but it goes into the atmosphere. So, to some degree, the people who are focusing on climate change and looking for a solution are doing the worst possible thing and actually accelerating the climate change because they're based on the wrong theory, which gives them the wrong cause. So I actually think of the thermodynamics and quantum mechanics as similar because both are based on a statistical rather than a physical model approach. But that leads me into what you're talking about, lost in math. I think Einstein shifted things from having a nice physical model to just, if you do valid math operations, then everything's okay. And they don't keep constrained by a physical model to make sure that those math manipulations make sense and have relation to what's happening in the physical world. And
Yeah,
I
yeah,
don't,
I
I,
think, yeah, go ahead.
I don't want to say too much because then I'll be repeating myself in 2 weeks. But anyway,
No, no, no.
but
No. I'm going to spend half the time. I just want to hear the story that of you with uh, the uh, the Institute for
me,
Einstein in Germany, right?
yes,
That to me, I'm not going to. Nope, you're not going to talk about that because that'll be 2 weeks from today. So, that's an absolute problem in general. Is no physical model for anything. I
yeah,
mean, we are constantly. One of the things is, well, even with my dad and my work, we're kind of redoing our book on what we're looking at the universe, how it works, and the thing is that people have come up with empirical equations for forces, right? They've come empirical equations for gravity, for Coulomb's force, for all these different, the weak force, all these force equations. And they are exactly that. They are equations that help us do predictions under those forces.
mhm,
They do not tell, and the problem has become is that with math now, we've now look at those things and we treat those things as if they're somehow physical. I had a when my dad and I were first writing our book, the particle model, or now what I call now the universal uh, uh, universal movement classifications in physics, that we've classified all movements in the universe. That's what we claim, right? Regardless, when we did that, and I was showing these ideas to a fellow colleague in computer science, he comes back and he goes, "Well, what are you talking about? I mean, gravity is a push. Gravity couldn't be a push. It's an attraction." And I said, "Well, what do you think it is?" He says, "Well, it's space time." I said, "Well, space time is space is nothing. Time is a concept. There's no physicality there." He goes, "Yes, there is." And I go, "What it is? It's tensor equations."
yeah,
And I'm going, "You say that again. You're saying to me, a mathematician, that tensor equations are physical." And people can't. I mean, I was blown away by that. And I think that is one of the problems, this kind of thing lost in math, even though Sabine kind of touched upon it and kind of tiptoed around it so she didn't step on too many eggshells so she wouldn't ruin her career. Um, it is true in general. The mathematics that people have, they even like I think Eric Reeder, who's in our room, who's given a number of talks on his work, he's looking at quantum mechanics and he's saying, I've got a lab, I'm looking at the data. This is what I see. It's the interpretation, it's the physical interpretation that you have two particles that you supposedly sent one and they're in two places. I mean, it's absurd. You can't have that. You can have maybe in our the way we explain it, there's more than one particle. Every time you shoot one electron, you're really shooting more than one particle. That's fine, and you can explain that. But this whole idea that then once they get all these experiments, They then start making the physical world from observations where they say there's two particles in one place. It's they're working from empirical equations and making that somehow into a physical world. And it's just, I think that's where we get into trouble. We just don't have a physicality for inside the atom.
Right.
And people say that the quantum world's really weird. Well, what's really weird are our ideas about the quantum world. It's not weird.
And
It's our,
that's Einstein is relativity is observer centric rather than physical model centric. He says that all observers in any inertial frame are equally valid model of what's going on, even though all of those views disagree with one another. So,
yeah, I mean that's the problem. When people talk about relativity and that, it's the frame of reference. Like, okay, so I'm on a train and you're on a train and there's a light source. And they go, okay, all right, but on the train, the light source has atoms, right? Okay, so each atom that's running around and each electron that's a frame of reference, right? So then you yourself are made of atoms, and those all have frames. So every moving
yeah,
thing has its own frame of reference, so that all the calculations have to be done. What's that all add up to for slowing down in mass increase in energy, etc.? It's just you get into if you use common sense, the thing kind of blows apart. But
right.
so what do you think? One more question I'd like to ask you is what do you think? I'm going to go back to a question I sort of asked in the beginning with you is why do you think so much of if you look at it the list again if you look at our list this is a wholesale list pretty much of physics and cosmology.
Yep.
Why is it that anybody who's a critical thinker who starts to look into this comes to this conclusion? Why is it that we're at a place like it's just all so wrong?
Well, you talked about that earlier, and I thought you hit the high points of not based on a physical model, but just going using math without constraints to a reasonable common sense physical model.
Yeah,
Um,
I think you're right. Yeah, and I think a good one is time, right? Is time a fourth dimension?
yeah, no.
Oh yeah, but see, there's the
yeah,
problem, right? Because where we got dimensions, we had three of them. They came from our observation of where in it, and we say, okay, we can pinpoint any place in this what we call space with three dimensions. And the dimensions we then gave mathematics to, and we gave them coordinate systems, and then we put a coordinate system, and then we had to say, oh, on this side it's negative, this side it's positive. Then we get into the math kind of problems. Then we also then say, oh, we have dimensions, we have our mathematical system, a dimension. We want one, two, three. I'm going to add a fourth one. They don't look at that point. When they added the fourth dimension, they didn't look to say, oh, I found it. Time is maybe the closest thing that perhaps could be contrived to be a fourth dimension because you can say, ah, here's a point, but this spaceship's not here at this time and it is at this time. Okay, but that's really movement. But the mathematical system of one, two, three contained into four to five to six to seven. And so we immediately, just with the fourth dimension, go into math and completely away from physics.
and then when we have empirical data that isn't consistent with our math model, it's treated like a math problem. What what equation do I have to add to get the data to match my theory? So they add, inflation to the Big Bang, which is a pure math construct.
Right, right. So yeah, I mean that's one of the reasons I think there's been a very large push to um, in the dissonant world to come up with replacements. An eternal. I mean, the eternal infinite universe just totally makes sense. I mean, people have coming up with models with ether, the particle models, the lattice model, all Newtonian. I know people here. Those are and I think the thing about the Newtonian, Nick, is whatever model ends up winning out, they do have one thing in common. they all are trying to say the world is the universe is physical. Let's stop this nonsense of not having a physicality to everything that we see. And I think that is what drove me to really look at different people's models. I looked at a lot of people's work, and I have subscribed to a lot of people's great work. Your work. I've subscribed to many things that you've said. I've taken those things upon myself to believe those same things because I've seen your logic. Somebody who's thought about, you know, relativity is an observer theory. It has nothing to do with physics. And when you see all those things, infinite universe, like Borchert said, all the way up and all the way down. The idea that how could a particle organize itself, one particle, that'd be the God particle of the universe, and organize itself and do all these dances and all these kinds of things. And so I think the need, if you see the trend today in critical thinkers, it truly is our people trying to come up with a physical model. And I think that's why they're going back to Newton, because the moment you get away from that, even charge is a magical thing. We put a plus on this, we put a minus on this, and magically they come together. So, okay. All right. Thank you so much. Any other closing comments, or you'll be in your green room. You can just wave your hand anytime. Any closing comments you may have, or
well, I think Professor Unziker was also correct that the problem is compounded. One, the people in academia are humans, and humans tend to want to defend their own ground, their own ideas, particularly after they publish them, because then it becomes part of their identity. But because of computers and particle accelerators, now we have tons of data, and the computer can help us define in that tons of data the thing that supports our theory. Whoever the experimenter is has a theory, and he usually is looking at the data to confirm his theory. If he confirms his theory, champagne is popped and he's a Nobel Prize winner. But if he doesn't find what he's looking for, then he's a loser. So it's a system that's self-perpetuating, going on the
yes,
wrong path.
yes. If you ever seen Unziker's channel, and he interviews David so and so, who supposedly got rid of the 19 physical constants in the universe down to 4 or something. You can see Unziker just ask a few very basic questions and just destroy him. He just falls apart in front of the camera until he's leaning over, taking his microphone that's in his hand. If you haven't seen that, folks, go out there and take a look at it.
I mentioned before that the problems that Unziker found in particle accelerators, that same syndrome exists in cosmology. So yes, from the smallest to the largest, that syndrome exists.
Yes, and the syndrome is kind of like predict a signal that you haven't found, look for it in the mess of the world, find it, declare yourself victorious, and get your Nobel Prize. That's what they do. They did it with gravitational waves. They did it with the Higgs boson. And if you read the Higgs fake and you look at the way they do science, if you took it to a committee at any engineering institute or university around the world, in a few hours, they would deem this non-scientific, not scientific, using anything that's even close to scientific method. Yet we spend billions of dollars working on building these hadron colliders and large hadron colliders, and to what? To give a few people some Nobel Prizes. I mean, it's kind of sad. So, okay, Nick, thank you so much. Thank you.
Thank you.
Okay. So, interesting enough, just looking at some of the comments here. Richard Jess, very good question, and I agree with Borchert on this 100%. He says, I'm questioning whether any two things are really identical electrics, for instance. Absolutely. Absolutely. If you spend enough time and you haven't read Glenn Borchert's infinite universe theory, at least about the infinite universe, that you can't have the smallest particle and you can't have the largest structure, that it just doesn't make any sense. That when you look at it, and you believe that there are no partless parts, meaning you don't get down to one thing that just can't be divided, like an electron. That according is an elementary particle, can't be divided. No, I mean I am with Borkert on that, and that is the universe is infinite. There are no partless parts. You can't have a something that doesn't have parts. It just doesn't happen. It goes down infinitely. Yes, and when you do look in that, and you start to look at that, the idea that you could have identical anythings is almost gets preposterous if you believe in that. So this whole idea that there are no two things identical, yeah, I 100% agree. It seems weird. Look at the universe. Look at the cosmology level, right? Look at planets, um, moons, planets, stars, all that. They're nothing identical. Why would we think that all the atoms, even though they are more regular, absolutely. Why would we think that everything would be identical about them? So that's very interesting. So we have more people in the green room. We have Ian. We have Franklin. Franklin's waving his hand. Hey, Franklin, how you doing?
Hey, yeah, I think that's a very interesting topic. So, I got your list here. So I just want to make some comments. And I guess my main comment is that the things we should throw away are the things that we don't actually have good experimental evidence for.
Right.
But the flip side, if we do have good experimental evidence, then we should not throw those things away. So I think, for example, say relativity, I think, there are some things that work there, like the Lorentz transformation, the whole c squared minus v squared over square root, that thing. That is very useful. And so, if you want to make an accelerator that's accelerating particles around a ring, the mass changes, and you have to kind of use that, not unless you want your particles to go, fly all over the place. Although in most cases, we don't have any use for that. But things like this whole space-time thing, that's like kind of grabbing at straws to try and explain,
It's
something.
just, yeah, the space time is no different from Newton. And Newton never, the thing that it was, the difference between Newton and Einstein, I'm sure Newton had an ego. I'm sure he developed one. But he wasn't scientifically egotistical. He always said in more or less these terms, don't ever accuse me of knowing what gravity was or what light is. I can give you equations to describe its behavior, but I'm not going to be able to tell you what it is. There's one thing I do agree that you look at evidence, but there is one thing I would caveat in what you said, Franklin, which I think were pretty good statements, and that is that if you have evidence for it, if you have experimental evidence, then yeah, we have to keep it. Problem is, let's look at a couple of things. Neutrinos, I'm not going to get into that. They shield neutrino detectors from false hits, right? And the more they shield them, the less hits they get. So there's an example. You get suppositive evidence for neutrinos, but you can explain it with something else. So what they call evidence is not always evidence. Another good example, Eric Reeder, his work and his laboratory for quantum mechanics. He is getting the same evidence that other people are getting in his lab, but he's interpreting it in a very different way. So what I would say to you, it's not only that you have evidence for experimental evidence for things. You got to look at the interpretation of what that evidence is.
Yeah, but
Because
some of these
sometimes,
things we
yeah,
have basically no evidence for, like dark matter. I mean, at least they're calling it dark, or dark energy. At least they're calling it dark because, they have no clue what it is. I mean, you can't find something if you don't know what it is, right? So,
well, they're trying. In fact, if you ask Neil deGrasse Tyson, I remember him being asked this about 10 years ago, what's the biggest thing that we don't know in science? And he goes, dark energy, dark matter. When that's found, they'll get the Nobel Prize. So they're trying. They're
yeah,
trying.
they're trying. But like I said, it's very hard to find something that you don't know what it is, right?
Absolutely. Absolutely.
But that
Yeah.
would be an example of something where there is really zero experimental evidence. I mean, actually, in the case of dark matter, there's even zero theoretical understanding of what that could be. I mean, what we do have is we have, the actual, evidence that they're looking at, which is galactic curves and that sort of thing. And as a dissidents, it's still our job to explain that in some way that doesn't, invoke, say, dark matter. I mean, that obviously that's pretty obvious.
Right.
Just obvious give up. But although some of these things like black holes, so they recently actually imaged one of these things. So,
well, they claim to image them. Okay.
Yes,
they claim to image them. And if you look at that.
Picture. So that I thought that was kind of interesting, because me personally, it's like, okay, you show me a black hole, as soon as you orbit a satellite around one and show that it has the characteristics that you predict, then I'll believe you. Although I also think that seeing is believing. So if they were actually able to
yeah, that was done. That was, if you look at how they generated, it's very, in my opinion, very suspect. And a lot of people it is. So, are they looking at something? Yes. What it is something interesting, black holes. But, I agree. I mean,
the other
black,
thing about,
go ahead.
Let's say quantum mechanics. So, I looked up like the wiki definition for quantum mechanics, and it isn't even clear what they're talking about. I mean, there's just like, it's not even one thing, really. It's
yeah, and it's so funny because they
electron orbitals and Heisenberg principle and a bunch of other things. The one thing that you did leave off here is, but I think is part of quantum mechanics, which is atomic structure, and that goes into say, because I have a recent discussion going on about, say, is strong force, right? And so there's another thing, is like, I asked the direct question, can you show me one experiment which directly, shows the existence of the strong force? Now, the answer to that is no. I mean, the existence of the strong force is predicated upon the gold foil experiment, which presumed that, the protons are all packed together in a little ball, which goes back to, the atomic model structure. But the thing is that I don't think we should believe in concepts that we kind of believe in because there isn't anything else better to believe in. That's like dark matter and dark energy. The only reason why we believe in it is because we don't got any other better.
No, it's a fudge factor. I mean, when a person puts dark in front of it, it's a fudge factor. It's saying we can't account for the velocity change on the edge of galaxies, and it doesn't work with Newtonian. But we've already shown that false.
So like the strong force.
I'm talking about that. If we have people that have shown Newtonian forces. The problem with the dark energy, dark matter, is that Newtonian forces can describe the different speeds of the edge galaxy stars. I made a video on this. Cameron Rigvisall in our group showed that you do calculations when you calculate the gravitational field of a galaxy, which is super complex. It is not a sphere. When you calculate that, you will actually very easily get the right prediction with Newtonian gravitational mechanics, the speed of the stars on the outside. So we don't need it. Newton can describe all those things. We don't need anything funny like that.
The evidence that you put out, which was that actual spherically distributed galaxies don't have any dark matter.
It's so obvious.
Because that's the only place where the standard Newtonian laws work in sphere.
Right, on the edge. When you calculate it, it's going to be spherical because it is a sphere. When I saw that, that's absolute proof of what Cameron was showing. And here's the other thing is people say, no, you can make it a sphere, you make a galaxy into a sphere. No, you can't. Ask a NASA scientist, ask a SpaceX scientist about how easy it is to just calculate the trajectory of a rocket going to the moon with both gravitational fields. It's difficult. And so just with two bodies, it's very hard. You've got billions of bodies in a galaxy. So it's quite amazing.
It's like, I think Newton, it came with the simplification that if the body is spherical like the Earth, then, it follows, you can treat it as if it were all concentrated in the center. But if it's not, like a big disk, like most galaxies, then no, you can't make such a simplification.
No, you can't. You can't.
So that's
Um,
like the whole dark matter thing.
this
And
this when people don't understand that, when I'm talking to somebody and they go kind of the eyes glaze over, I said, here's an easy way to think of that. Imagine you send a probe to the center of the galaxy, and you're going to send it through the arms, right, in the sphere, in the disk. You're going to send it this way. It's going to be doing this because it's not going to have. You're going to have one, more gravity over here because of more stars and less over here. It's not going to be a straight line. Now, if you do something above it, way above it, the the gravity is going to be more uniform because that's the way the gravitational field is. So it's, people can get that, but we have so much that's going on with dark energy and dark matter, and we've explained it away. People will cling to that idea because it's a prize out there. It's like particles. A particle is a Nobel Prize waiting to happen, right? If I discover the particle for dark matter, I win a Nobel Prize. So people are wanting to do those kinds of things. So,
yes,
okay.
what you have on your list though is quarks. Now I see we do have some comments here. So
Yeah, I do. Yeah, let me just do a few. I did see that here. This is one.
where you can look at
Andrew
so
Castro. Yeah, but no, Andrew Castro did an experimental, did his thesis on nuclear collisions. Here's Andrew Castro. Here's what I would say. There is a paper by Dr. Carazani, who talks about nuclear collisions. He wrote a paper on the mathematics of nuclear collisions without relativity. Why did he do that? Because he found a mathematical and conceptual error in relativity, fixed that, and came up with what are called Newtonian autodynamic equations, which you then use in nuclear collision. If you use Carazani's equations instead of the relativistic equations from relativity, you use Carazani's equations, no neutrinos are needed. And so the neutrino was invented to keep the ability to use relativistic kinematic equations at the collision in nuclear collision is one of the things that he actually calculated. So if you do nuclear collision, I'll find that paper, put a link to it. Carazani by Occam's razor wins because he has found an error in relativity, special relativity equations. They become Newtonian, very simple. And then when you apply that to nuclear collisions, there's no need for neutrino. The neutrino's linked. So you have special relativity coming out with extra energy, invent a neutrino to take it away, or you can find the error in special relativity, apply those new equations to things like nuclear collisions, and explain them perfectly well. All the energy balances out. So that's what I say.
my problem with quarks is that it's all math, and that is
Oh yeah, quarks. Well,
but the thing is that no one's ever been able to isolate a fractionally charged quark in an experiment, and they've tried, and there is actually no theoretical reason why you shouldn't be able to do it.
Right.
That would be evidence for a quark. If you could say, there's the quark in the cloud chamber, it has 1/3 charge. It's not an electron. It's not a positron. It's a quark. But the amount of evidence for that, goose egg.
Right. But let me just say this as well. If you read the Higgs fake and you understand how quarks and all these other particles were found in the first place, you will have to, if this was up in a court of law and you say quarks exist, and then you say, okay, show me your scientific method to find them, you'd be in big trouble. So the scientific method that was used to find them just would negate quarks in the first place.
Well, like Bill Lucas's test for this sort of thing, I think is very good, which is that if it really exists, you ought to be able to form a beam of them, and then you can play around with it. Like you can take a beam, you can turn it on and off. You can see your detector turning on and off. Then you can say that, you've actually got something there. So it's like most of the, particle zoo don't count, including
right. Well, yeah, if you look at what Dr. Unziker says, he says throw out particle physics from the 1930s on, which basically throws out the neutrino and everything else after that.
Although at the risk of triggering you, they can form a beam of neutrinos, and they did send it to a distant lab, and they did.
We have an explanation for it. Let me tell you this again. I'm going to say for the 1,000th time. When they have neutrino detectors, they shield them. What are they shielding the neutrino detectors from?
Yeah, but if you can turn off.
Wait. Answer the question. Answer the question. Why do they shield neutrino detectors? Detectors.
To shield them from the other neutrinos coming.
No, that's not the answer. Ask a neutrino scientist. They shield them from false hits.
Yes.
That is, their neutrino detectors can be triggered by something other than a neutrino. This answers Andrew Castro's thing too, the question as well. This is from neutrino science, from mainstream. Okay, listen again. What they are detecting. No, listen again. What you're trying to do is explain the neutrino and ignore the false hits. When they turn on a beam of what they call neutrinos and it goes to somewhere and they detect it, yes, they are sending something and it's not neutrinos. It's something else. It's the same things that can trigger a neutrino detector. Hello? So let's just say this. Neutrino scientists know that beta particles, most likely alpha or beta particles are what they are, which are nucleus of atoms traveling, nucleons. That's okay. You'll say to a neutrino scientist, let's call this particle an alpha particle. That's going to be the particle we're trying to shield. Is that correct? Yes. If that alpha particle gets through the shield and it goes into your detector,
you're saying that they're generating like gamma rays or something.
Yes. But what I'm saying is, if by your own definition, another particle can make your detector go off, then how can you tell me with a straight face that I'm shooting neutrinos only, and it's being detected only neutrinos, when you tell me that neutrino detectors can be set off by other particles? That's what they do. They bury them in mines. They do all these things. So what people try to do is try to ignore that and just say, oh, they need to balance out. Karazani always says that as well. For instance, Andrew Castro will say to me, of course the neutrino, it's the only thing that works. Nothing balances out with it. Of course nothing balances out with it because you're using relativistic equations, which are wrong, that require the neutrino to take away that dark energy, the extra energy. So that's what's happening. When they say they turn a beam on something, they are something. Absolutely. They're being detected. Absolutely. But neutrino detectors will detect false hits. That is admitted by the entire community of neutrinoists. So I'm sorry. You can't tell me that's a neutrino. You can't.
Well, you have to look at the specific, because what they're looking for neutrino detection is very specific.
Right, but that's specific. Right, but can that? Wait, no. Wait. You're saying specific. Can it detect a false hit? Will they say, if you go to a neutrino person and say, can you get false hits in a neutrino detector? What's the answer you're going to get from them?
That's why you have to be able to turn the beam on and off, so you can tell.
But what you're doing is you're doing other particles, not the neutrino, because you can't tell. You cannot tell. Even if you had some kind of proof, the detector on the other side can detect false hits, and you cannot tell me, and no neutrino person in a court of law will tell you, yes, I can now tell you that for sure those are neutrinos. We think they are. Okay, that's what I'm saying.
Well, that's probably technically true, but it's just interesting that is one way that you can eliminate most of its background event kind of thing.
I know, but you can't.
If you can turn it off and on, then you
can't, because when
then
they're sending particles. I agree, 100%. They're sending something and it's being detected. They're not neutrinos. So, okay,
but
that's fine.
I don't think there's kind of some evidence. So there's one where I would say that, well, they've actually dug up some actually convincing evidence. At least, I don't know, for me, but it's everyone's opinion anyways.
Well, that until neutrino detectors can detect only neutrinos, they're screwed. They're screwed. You can't do anything with it. It's like saying, oh, by the way, uh, Franklin, I'm going to put a detector in your home, and it detects carbon dioxide, right? Oh, by the way, it can be triggered by other things, but that's okay.
Well, that's why they bury them so that they can characterize the amount of background
And
noise.
the more they bury them, the less they get. Isn't that weird?
Yeah, that makes for a better experiment. So it's like
No, it doesn't make a better for experiment. It's showing that you're just blocking out the
like I said, I
particles detected.
you on that, but let's
Well,
go on
but yeah. But the other thing is
other things
too.
you have on your list here.
I understand, but let me just say one more thing. There is a theoretical explanation for why it doesn't exist, and it's directly linked to special relativity and the extra energy put into it. So I wouldn't just take my argument with neutrinos if it was just detectors. There is a real simple and logical explanation that Karazani came up with it. So when you put two things together, you have a very strong argument that it doesn't exist. So, anyways, as for the quarks and all those, because he's talking about the quarks as well, I think it's funny because I've talked with about quarks. I talked with what's the guy you were talking about with particle physics? Forgetting names. Bill Lucas. He said that he has friends in the particle accelerator world, close friends, and he told me 15 years ago that quarks, his friends who found quarks, they got to be right because he believed those people did good science. Or has he changed his mind? Or
No, I don't know. I mean, just one of those funny things among dissidents is that our dissident theories will often, include quarks. Like the Jeff Dee's energy wave thing. He uses quarks in his theories, and but there's a very big possibility that those things don't exist. So it's like, what does he base
right,
theory on? I don't know. But I could be
right.
wrong. You could be right. I don't know. But it could be that a lot of these things that we see here, even a dissident this theorist might be trying to include them, even though they might be wrong. So that's another kind of interesting,
Right.
point here. Like, or you have a distant theory that includes the existence of strings, right? So this is
Uh-huh.
another thing which we have, like, absolute zero experimental evidence for, nothing.
Right.
So, and
Right.
maybe that's
Right.
perhaps why strings have kind of gotten out of fashion. It's kind of funny how that theory has just, even in mainstream, has become, a kind
Right.
of a really. So
Yeah. Yeah. I mean, there's a person, Jose Silveira, probably Portuguese, José Silveira. He says neutrino detectors are as reliable as gravitational wave detectors. As you said, they are Nobel Prize detectors. Yeah. In fact, I had a meme that showed, the Hadron Collider, that famous photo, the ring and all that looks so impressive. And I said, the world's largest, and at the bottom, Nobel Prize to generator. So,
that's right. They detected one, and no matter how big they make it, they don't seem to be detecting anything else. So
yeah, well, the whole endeavor. I think the only good thing is we've got Sabina Hassenfelder out there saying we shouldn't build the bigger one because we're kind of not justifying our science where, yeah, right now. So,
yeah,
okay,
that's the
well,
same problem. They're not going to get any more money because they said that would be the worst disaster if they found the Higgs and nothing else.
right.
Because if they did, then they could justify that. Hey, if we only had it this much bigger, we could go find the next thing. But unfortunately, even with all the energy that they have,
Well, you got to think of it. You got to also think of it this way. I always kind of talk with people. Oh, by the way, this is a question answered for. I challenged Andrew Castro. They're just talking about evidence for neutrinos. They said, first of all, you're going to have to unexplain Karazani's findings, which I think are correct. So people want to know about Karazani's work with neutrinos, just go to neutrinos.autodynamics.org.
And also,
So,
Bill Lucas is part of our group, and he's a particle accelerator expert. So,
oh no, he is absolutely, and I'm not questioning I'm not questioning him. I was just confused because one time he told me how he's got friends in the business and he trusts the way they are doing the science to get the information. So I'm not. I agree. He's a brilliant man. I will not argue there. What was I going to say? Sorry about that. Okay. Yeah. So, any other comments on this thing? I know people. Let's see. The real number system, dark space time, strings. I don't know. I guess strings have kind of are out there because they're grasping for straws still. I mean, what's your thought on that? I mean, strings are so absurd, in my opinion. I mean,
well,
what's your
was something based on math, and it seemed absurd, and it should have really stayed that way. So, I mean,
Yeah, it was literally the people who came up with it said on the outset, this is a non-physical, completely mathematical exercise, never to be taken seriously. That's what they said. And what happens is I think in the 20th century we believe almost in anything, right? Magic.
well, they
And
didn't stop until they had to come up with like 12 dimensions or something to even make it work in their mind, right?
right. Here you go. I don't know if this is sarcastic or he's really saying this. He says, Phil Magic. Trust me, I'm a scientist, right? Yeah, that's one of the things we have to do is you gotta make your own minds up, people. You really do. So,
I mean, we got to stick with kind of the things that we know, which electrons and protons and neutrons. Some people even question the existence of positrons. So, but if someone questioned the existence of positron, then yes, I could show them a pile of experiments, and this is where they're in cloud chamber. This is when they're ejected from pair production. This is what happens when they collide, and that positron is not a proton. I could show them a ton of experiments,
right.
but that would be like an example of what you keep. You can keep
Right.
the positron because you do in fact have this ton of experiments.
Well, it's a particle, what it really is. But, sure.
But you can throw away quarks because we don't have.
Yeah, I mean, until somebody comes up with it, if it's real, then somebody will come up with it. So, okay, Franken, thank you so much. And I guess we'll see you guys next week. You and Ian will be here with.
To set up a test, and like after this.
Don't worry about that. The whole problem has to do with a code. So you just have to log in and then get a code. So we'll figure that. We'll get that done for you guys.
I
but it'll be great. But you guys have been doing some alternative Saturdays, right? Yeah. Tell us a little bit about that.
Well, this is just kind of a continuation of just the more the chat model, I would say. Although we do have specific topics, so. I'm all for people who.
Oh yeah, no, I guess we've got
speakers and topics. So
right, okay, all right, I'll get. All right, thanks a lot, Franklin. Appreciate it.
But tune in for those. So.
Yep, tune in for those for sure. Next week we'll have Ian and Franklin. Andrew, I believe you, but again, it's Occam's razor. If you use special relativity, which requires a neutrino. It's just going to be a simpler model. Relativity has too much baggage that comes with it and creates too many problems. And a simplified model, for instance, even the autodynamic equations over the SR equations is just a simpler model and Newtonian at that. So I believe you, of course. In fact, people publish all the time with using the neutrino and relativistic kinematics with the neutrino. It balances out. You have to have it. That's why. So I believe you. It is a system. It is a system that everybody can consider. I have considered it, and I just think simpler systems and the relativity is just an observational, observational theory, as stated by so many people. Peter Marquardt said that. Of course, Nick Percival said it. Many people said it. I think even Glenn Borkert. So that you're basing on the special relativity, which if you look at it, has its own problems. And if you have somebody come along, find the problem, correct it, get a simpler thing, neutrino goes away. To me, that's the story. So, but again, congratulations on your work. Um, you know, everything we could be saying is wrong. That's the way it always should be, and everybody should be able to cite their work. So, all right. And that's why I put it up there. So check that out. Hey, Ian, wave your hand and maybe tell me, you can even come on and tell us a little bit about maybe what to expect on Saturdays. But of course, you always have opinions about this as well. Let me take this banner off. I need one of the things we're going to have to be, oh, no, see, I did that wrong. One of the things we need to do is once we have Ian and Franklin, hopefully will be helping host these, and maybe we can get Franklin to do the production because it's hard to host and do all the chats and all that stuff. So maybe you guys we can get two people working together where one talks and the other's dealing with all the other chat stuff. So anyways, let me bring you on. How are you, Ian?
Very well, thanks. Hope you are as well.
And so let's just first, I want to get your opinion on this list.
That's right. Yeah.
Yeah. Give me your take on this
first, if I may.
Yes.
So, actually, I think, David, that almost everything on that list is suspect, but in a different way. Some of those things would appear to be mere fudge factors. You've accepted some theory already, and then it's not quite giving you the result that you predict. So you introduce some factor to save the theory. So that's more suspect than others. But I mean, for my part, I wouldn't ditch everything. I'm trying to look at this thing positively. All the experiments that have been done, and maybe the wrong directions that have been taken, we can actually learn from them. It's a bit like the antinomies of Kant, or sort of develop more into the Hegelian system of thesis and antithesis, and then synthesis. Well, you might find that some of these things are 99% false. They're probably not 100% false, but they're 99%. So you get the antithesis, and then you find, well, that's only 1% false, and then you get the synthesis, which brings you nearer to the truth. So I'm not so pessimistic about these things, but I do observe that we seem to be concentrating on errors in more recent science, particularly 20th century and also into this century. Maybe we're not so critical of earlier science. I would be as well. I mean, as I say, most of these things are suspect to me, but I'm not going to be so negative about them. When you say relativity as a sort of a global word, well, I sort of accept the tenets of Galilean relativity, at least in an ideal situation. So it's only the more recent manifestations of them. And again, quantum, maybe some elements of quantum theory, the whole of quantum mechanics, I think, has probably gone a bit astray. All right.
Yeah, but you're right. I think one of the things you said is kind of interesting is if you look at the people who are, I'm going to put this back up here. Replacements. Looking at people saying, well, what do we have if we don't have that? You have these types of models and things. They do stand on things that have been around for a while, but they're not recent, like you said. It's interesting that there's how much that's actually could be a whole topic. How much of the 20th century, what have we gotten from it? I think if I were to look at the 20th century's strongest point in physics, it would be the periodic table. That to me is a very hard thing to argue away. Now, what's happening below inside the atom, that's up for grabs, I think, in a lot of sense. But that part of it, if you look at the 20th century, all this other things in what we call theoretical physics and in particle physics and even a lot of cosmology, one of the things that I think we're a little bit more trusting of cosmology, because one thing that I did get from going to and having followed Karazani talking about physics as astronomy clubs, astronomers had this kind of not hatred, but disdain for physicists, because what they always said is that physics is based on stuff none of us can see, and astronomy is only based on something that we can actually see. And they always had this as a you can point your telescope up and see this. I can't go, you and I can't go to our kitchen and find quarks, right? I mean, we can't do that. And I think that was one of the interesting takes I had, at least in the 20th century, of what people thought of the particle physics. So I do agree that there's a lot of stuff that we can keep, but how much of the 20th century physics and cosmology, especially in the theoretical side, that's up to debate, I think. So, all right, tell us a little bit about what's coming up in the that you guys have been talking about in the Saturdays, because we're going to start broadcasting these on these Saturdays. Can you give us a little idea of what kinds of things have been being talked about? Because they're very interesting things. They're a little bit more in depth for sure, but
Yes.
maybe tell us, give the audience about what I call the more in depth kind of Saturdays we're going to be having coming up starting next week.
Okay, so with regard to that, last week we had a most interesting exposition by Harry Ricker on the question of unipolar induction. So this is a particular problem which has sort of confused physicists and electrical engineers, and there are different theories floating all over the place. And yeah, that's it. And actually, I might say that Nick did a very good job of sort of editing out all the messing around, because there were teething problems, largely caused by my experience, I think. But anyway, so there's now a coherent view that one can get on the Nick of Time channel, which is quite interesting. Now, right. Harry comes to an interesting conclusion, actually. He's done a lot of work on it, and you talked about his writing capabilities. You'll find that on the links that you talked about. He's gone into great detail, historical detail, and so on.
Yes.
But, his disconcerting conclusion was that we're just getting nowhere. We're more confused. There's no point in doing any more experiments. All the experiments have been done. And even what has been done up to now might indicate that the scientific method is not working. Now, for my own part, I think that's maybe overly pessimistic, but we're going further into this now. And now, so I didn't actually know. We're in discussion, I suppose, over the next week or so, David, with Franklin and you and me and Nick and Harry. But I thought maybe Bob Gray would be doing the next one, because he's been working very much on the Weber electronics theory, electromagnetic theory, which is one of the theories which seems to be consistent with this. So we can talk about that, but I don't. If Harry wishes to give a further talk before that could be.
No. Here's what's happening, and I'll tell everybody. I put this down because I didn't really know. I wanted to announce it. I want to say there's something happening next week. It may be changed. That's always the case. So I just put this down. I had noticed some talk about this amongst you. So please forgive me, Harry. This is not a commitment on anything, because as people know, we will sometimes have to not do even a whole broadcast for a weekend because something comes up. We're not professionals. I mean, although please do consider just any type of donation would be really great. Let me put that up there again. We are having our fundraiser. That really is helps out. I know some of the people here that have. I want to thank everybody who's contributed. But one of the things that will allow us to do is to have these other things like the Lifetime Achievement Awards for people who are well deserving, and we have many more to give out. We really do. So, I would say, in general, the talks that you have for I'm doing this wrong. See, look, I'm even inexperienced in doing this. But the things that we have on the more what we would call the more in-depth days, you're talking much more technical stuff more normally. Is that correct?
Yes, I certainly would say so. But I think any of our intelligent audience people, even not specialists in this area, people who have some scientific training, would be able to take
Yes,
apart.
no, absolutely. I mean, just the concepts themselves. I mean, you guys aren't literally going and discussing the nuances of equations, right? I mean, you will show equations, I think, once in a while, but you're still coming from the how do you say the 50,000 feet foot level, because you're always behind all these talks. I notice there's always a big question behind that, and I think that's where people can hang their hats on that. So.
And the emphasis is certainly on the physical.
Yes, on the physical, absolutely. So, okay, well, we look forward to that. So, all right, well, thank you so much. I appreciate your comments and look forward to it. Again, we have people in the green room. If you want to come and visit us, you can. Let me put that up there. We do have people who will do that now and then. Put this into your browser, and you'll be able to come up and talk with me about the topic of today, which is, of course, what do we keep and what do we throw away? I do want to once again say, since I do have a little bit of time here, to tell you that please help add to this. This is not a live page. This is cut and paste. So hopefully some of you have donated. You can donate as little as $10 from anywhere in the world. And the idea is if we can get up to this 3,000 level, we'll get to a bank account where we will have breathing room. So I don't have to worry about how we're going to pay the next subscription bill. And again, there's about $2,800 to do all these things online that we do for our organization. So it would be greatly appreciated. And yes, I know this is above and beyond people's memberships, but if this is kind of the thing I do every year, shake the tree. And I know there's lots of people who don't have the funds. And if you don't have the funds and you want to support us, hit the like button, hit the subscribe button. That's what will help us out. So I want to thank you. But if you are a person, maybe you're retired and you have some funds, some disposable funds that you want to throw in a direction you think is worthwhile, well, this is absolutely a worthwhile, because you can see we're here, we're discussing. We even have people in our chat who are more traditional physics people. We don't make fun of them, or they don't make fun of us. It's very cordial, but we should have these kinds of debates, just like we should do in politics, where people are oftentimes pit against each other instead of trying to work things out and have discussions. So anyways, if you can do that, that would be greatly appreciated. So again, if you want to come into the room, we do have 10 places available in our green room. So think about coming on. And you don't have to show your video. You can also do it just with audio. All right, so I'm going to take a look at some of these comments and see what we have. There are people here, just some ideas for those people who are kind of new to this. There's ether theories, and ether theories claim that there is a bunch of particles, much like air are particles out around us right here, and that light is a transmission through that ether. It's a very common model that people talk about. It was very, very, very popular in the 17th and the 18th and 19th centuries. And people look for it. They claim to have proven ether doesn't exist, but that is still a viable, in a lot of people's minds, a viable model. So that's one of the things people find. A lot of times this kind of brings up the idea that we get oftentimes as critical thinkers who will challenge all of these things, is that, well, you guys always challenge it, but you can't take something down unless you have something to put in its place. And that's absolutely true. And but we do have people working on those things. Again, we do have people working on Newtonian models at the quantum level as well. Ether, and again, those things are out there. So do we have them? Yes, we do. Where do we have those things listed? You can go to one great place to go is Beyond. I think I can put that in the banner there. Beyondmainstream.org. That's our magazine. Do I have a banner for that? Yes, there he is. So there we go. If you don't believe a couple of things, one, that all these things that we talked about are not true, that is, that these things like come on, come on. There we go. That these things we're talking about, which are considered to be all, most of them settled science, how these things could be suspect, as Ian says they are suspect. I think Ian has the same kind of model my dad has about the world, and that is we're just going to try to come up with things that are less wrong than we have right now. That's really kind of the real engineering way to look at it. But if you don't know that there are problems with it, go to beyondmainstream.org. It's got a lot of great articles about most all of these areas. And we literally have thousands and thousands of books and papers written on why these things are incorrect. And we also have many, many models out there, many books with new models, with new equations that attempt to solve these problems that mainstream has. So you do want to kind of check that out. Alrighty, let's see what we have. Let's see. It says the ether model would be solved pretty quick if SNM redos MX experiment without laser but white light. Okay, that's interesting. So again, if you're kind of new to this, ether is supposedly a medium through which light moves, and if that's the case, then somehow, I'm not an etherist myself, so I'm a little skeptical, but I guess the idea there is ether stays in the space somehow. It stays around, doesn't move. It may move some, but it's kind of like almost a frame of reference, and the Earth moves through it. And the Michelson-Morley would say, if I'm moving through it, then I should be able to detect it. But of course, there are etherists who say, no, ether is entrained, that it gets stuck around the Earth, and therefore you're not going to measure any difference. So they explain that difference away. And then other people say, no, I do want to redo the Michelson-Morley experiment, which basically tries to measure light going in one direction versus going in another. And if it goes faster or slower, and you can measure that, then you would say, well, that would be supporting the theory of ether. Again, be careful. There's no proof for anything, folks. There's only support for your idea. Proof is really a mythical monster out there that we kind of come up with, but that's what that is. Whoops, sorry. Yes, condensed ether is actually ordered flow or otherwise non-ordered ether particles. Again, a lot of ethers out there. Let's see. Here's another comment. Andrew Castro says things. Oh, he's talking to Andrew. Things don't know how to be physical. But if it is not physical, then the only other option to explain how the phenomenon works is nothing acting or something. Which is illogical. Yeah, I mean, what he's saying is we got to have some physicality to forces. If you don't, and you think that's the way the universe works, it's kind of totally illogical. I think that's what that kind of statement is saying. Roger Parker says, I wrote a book, Myth-Busting Physics, and I have problems with everything on your first list except for relativity and plate tectonics. Oh, okay, that's really interesting. Wow. I think it's funny because if I were to say the two things that I would bet my house on would be both relativity and plate tectonics. So plate tectonics is kind of somewhat right that they're plates, but that's I guess could be debated. Let's see, what else do we have here? Again, if you want to come into our area and talk with us, our green room is open. I see Harry is there. Hello, Harry. How are you doing? Would you like to come on and maybe talk about what... I'm not saying that you're going to come on next week, so I do apologize. You were talking about that, and I think some people were talking about you talking about that, but maybe just come on and give your opinions, first of all, on the topic of the day. And also maybe about these Saturdays that you have, which again, I will put that up there right now, which is if you go to nick@naturalphilosophy.org, you'll be able to see Harry. Harry's there. I brought him up here. You'll be able to see Harry talking as well as other people on some alternative Saturdays when we aren't here. So luckily, we think we've got it all worked out so that they can bring all their great discussions to everybody now. So Harry, what do you think about a list? Does this even matter? Or, I mean, this seems to be almost all of science that's kind of being questioned here. Hello.
Okay. What you've done is you made a list of what you think are controversial things in science, and I guess you could add things to this list. Okay.
Oh yeah,
I
for
wanted
sure.
to. The reason I wanted to come on here was you're hearing me pretty good, right? Okay.
Yeah, absolutely. Well, you're looking good here.
Um, Ian made a comment about my presentation, which you can go to the Nick of Time. Now, it might be hard to find that video channel because the
Well,
Nick of Time is the movie. And if you search for Nick of Time on YouTube, you get a lot of other stuff and you don't
okay,
get
wait.
that.
I'm going to interrupt you just to let you know. If you put in what I have right down below, it says nick.naturalphilosophy.org. That's a shortcut to get you to that channel.
Okay, that's good because
I want to make it
people might
easy.
have okay, make it easy to find that channel. Okay, now what Ian said was, I don't think he really understood what I was saying in the video that we did last week, and I made a criticism of the scientific method. And my criticism is the scientific method isn't really powerful enough to discriminate against different theories. And so what we were talking about was a paper in which these people claimed to resolve the Faraday paradox. And so what they did was they said, well, we're going to do these experiments. But what they accomplished was they allowed their theory, which was the Weber theory or the Weber theory, if you will, of electrodynamics, and kind of showed that that was able to explain the experimental results as well as other theories which could explain the experimental results. And so what they did was they added to the theories that can be consistent with the experiments. And so what happens in the scientific method, it's not really powerful enough to really eliminate wrong theories.
Yeah, yeah,
And
I understand that.
so in order to move forward, what scientists do is they pick theories that they like and promote those. And so your list is a list of theories that have been deemed good because the people who are in the top of the scientific hierarchy said these are good theories and we believe them and they make sense to us. And if you don't like those theories, they don't basically let you get your papers published. So the problem.
Right, right, absolutely. So, are you planning then to do some more talks on these similar subjects then?
Well,
Induction,
I'll
unipolar
talk if
neutron?
people want to. This
Oh,
issue of unipolar induction is kind of an interesting issue because we're talking about experiments that anybody can do his garage or his basement, and they don't cost a lot of money. And people have done these experiments in their garages and their basements. And the more experiments that get done, the more the debate continues. It doesn't really resolve the theoretical issues. In other words, it doesn't tell us what theory is the correct theory. It generates people with more theories saying my theory is correct. So in science, they claim that the scientific method can reduce theories. You were talking about Occam's razor earlier. The doing experiments and doing observations and spending all this money doesn't necessarily tell us what theories are the correct theory, because there's probably more theories out there than there are experiments that can tell us which theories are right or wrong.
yeah.
So
I
there's a
agree.
list of us that have become accepted in science that are consistent with the observations or the experiments, but that doesn't necessarily mean that they're the only theory or that they're the correct theory. And that's really kind of what I think CNPS is talking about. It's allowing people who have differences of opinion to say why they don't agree with the imposed theory You're saying, you're talking about imposed theories that the
Right.
establishment is telling
Right.
us are the correct theories. And it's kind of like the COVID-19 thing of Dr. Fauci, who says, I am the science, and what I say is correct science because I say it is so. And
Right.
he's the perfect example of establishment science and how it operates.
Right. No, I agree. I think that's a very good way of putting this. What I really have listed here are what people, mainstream scientists, have deemed the acceptable theory of today, and they're always saying the same phrase. Well, until you can come something better, then this is what we got. And I think one of the harder problems is in science is that is not a necessary way even engineering works or even software engineering works. Even when you write, I'm a computer program. When you write a computer program, or if you're an electrical engineer designing circuits, there isn't something that says, okay, I designed this circuit and this or this program or whatever or this machine, and therefore it's better than the one before. But until I can't just throw that machine out and then start over without another machine taking its place. That's kind of weird. It seems like that way. It's almost like if we throw out relativity, then we have nowhere to go, and that everything that we can't send probes to, the moon anymore or Mars anymore because we can't have it so that there was a theory there and we say it's wrong, but we have to replace it. I mean, I think that's also kind of a weird concept that we have to keep doing something stupid until we find, something else to replace it. And maybe like relativity.
Speaking,
Go ahead.
speaking of doing something stupid, climate change theory is a good example of political policy decisions being made based on science that really doesn't demonstrate anything is true. So, if you go to the nick of time, go to the talk on, and basically, is there really any evidence that proves that climate change is really real and it's really happening? And of course, this is a big issue because, the governments are all telling us, the United Nations is telling us that this is happening, and all this money is being spent and not to force people to believe this. Is there any
Yeah.
really scientific, factual
Well,
evidence? And
yes,
well,
it should be allowed to be questioned. It should be allowed to be
challenge to
questioned.
disagree with different, and
Yeah.
can't allow that to be questioned.
Yeah.
Well, problem. And if the scientific method isn't really as strong as we've been led to believe, it's kind of questionable as to whether or not scientific method works so perfectly that we can know with absolute certainty that all these things that are on your list are true.
Right.
Big Bang is a pretty good example of something that there's not a whole lot of evidence for, but we believe it anyway.
Yeah.
So we're making big social policy decisions. Governments are spending billions and trillions of dollars, and all based on a scientific method that's not really that strong as far as being able to determine what's true or false and what we should believe or not believe.
Yeah, we're not living in the logical world of the Vulcans. We're we're extremely emotional still, and that gets in our way. Did you? I don't know, Nick. Were you raising your hand to come into the conversation, Nick? I don't know, or were you not?
Anyway,
No.
I did a talk on climate change and the science behind it, and that's also on Nick's channel
Okay.
for
Okay.
anybody who's interested about that. Having brought this up as a topic is a big political no-no. So
Of course.
if
Yeah.
you get banned because I talked about this, I apologize.
No, believe me, we get banned for all kinds of other reasons, but we've been, it's doing pretty good. I mean, we're getting more and more subscribers, so I think they become less worried about certain things. So, but I agree. The whole thing about I always tell people when they ask me about climate change, my friends, because they know I'm into the physics and cosmology. My dad and I wrote a book and all that junk. They always come at you with these, generic equations. I go, okay, how far in advance can we predict the weather accurately? He said, maybe 5 days, sorta. Now, what we are doing with climate change, we're predicting how many decades into the future with a much more complex system. And they go, oh, yeah. So I said,
Well, I
everything should.
mainly brought that up because I made a video on, and since we're the work that we've done in the past, trying to get people to view those videos. That's
Sure.
really the main reason I brought that up.
Yeah, no, there's no problem at all. And that's why, again, go to nick.philosophy.org, naturalphilosophy.org. You can get to that so quite easily. So, okay, well, look forward to hopefully some more talks by Harry and other people. But next
Well,
week then
thank
we'll
you,
start.
David.
No, thank you. Again, check out Harry on beyondmainstream.org. Great writer. Congratulations as always. Always look forward to your talks and your writing. So thank you so much. All right, that's Harry. Harry's coming along in the world. I mean, you got great video and audio this time. You guys are training him well. So again, go to nick.philosophy.org and you'll be able to see those things. We're coming up on the end here. We got people in the green room. Anybody else want to make any? Raise your hand. I did want to comment on a really brilliant statement, I think, by Nick on the neutrinos. So I'm going to put this up here. Very, very, really brilliant. He said that neutrino detectors and neutrino telescopes are misnamed. I agree. Now, he really puts this well. They are not designed to detect neutrinos directly. They are built to detect what would result from a theoretical neutrino collisions, but what they actually detect can be created by cosmic ray collisions. See, that's why we have of Lifetime Achievement Award winners in my blue room, because this is exactly a great explanation. I'm going to remember this for the rest of my life with this. Very true. Neutrino detectors, in fact, I don't know if I have time, but I'm going to look it up. If you look up neutrino in Wikipedia, it's got, at least it did before, had a wonderful picture there. Let's see if it still has it there. Oh, yeah, there it is. So maybe I can bring that over here. Hold on. See if I can do this in time. Yes, it's there. So Wikipedia. And I'm going to go to this picture here. This is the Wikipedia. This is will emphasize what Nick is saying. This is, if you go to Wikipedia and look up the neutrino, this is a neutrino event from 1970. It's the world's first observation of a neutrino. It's kind of weird. So that's what you read, right? That's what's on the bubble chamber picture. And what does it have over here? It's got a proton path. Then it has collision creates. Then it says an invisible neutrino collides with a proton. Okay, invisible. And the neutrino transformed into a mu meson and a pi meson. So if you were to have a Feynman diagram, I'm sure you could draw this up in a Feynman diagram. So exactly is right what Nick is saying, that neutrinos are never detected directly. Even with the neutrino beams that they say they are doing, they are still detecting them in the same way. And that they can be triggered by something else. So again, look it up for yourself. But I thought that was very astute. Thank you very much, Nick, on that comment. So we are coming up to the time 57. So we only got a few more minutes. Let me see if there's any more comments here that I may want to put up here. That's why I really need to have perhaps Franklin come on these days too to help me out with these things, so that we put up the comments, because doing all this and keeping people, how do you say, engaged while you talk. Let's see. If light, here's an interesting statement. If light was a wave, shouldn't it interact with our atmosphere? Well, it does kind of interact with our atmosphere. So, let's see. We have climate change. The people are talking about. I will send you a picture of possible climate change written in rock. Yes, absolutely. That's true. Climate has changed over the years, with or without us, drastically, in fact. I mean, we've got ice ages, right? A lot of the theories there is because of where we are in the universe, whether it's are wobbling in the galactic wobble that we have in the Milky Way, etc. So very interesting. Anyways, let's see the times. We are requested cool about the net rotators. Yeah, I think the climate change that Harry talked about triggered a lot of interesting. Here's another one about plate tectonics and the expansion tectonics. If you are new to this channel and have not heard of expansion tectonics, look up Neil Adams and expanding Earth. You'll see a graphic that's extremely compelling, because it's not only that the Earth fits together in the Atlantic, it does in the Pacific spoonerism, which ended up in a completely different word. With plate tectonics, I will look at other words like, yep, you can look at those kinds of things as well. If you look up Neil Adams again in Expanding Earth, he also looks at, I think, the moon, Ganymede, and other celestial bodies, and Mars, I believe, as well. Alrighty, folks. I want to thank everybody for coming on. I do want to thank everybody, including those people who still support some of these ideas that are supported by mainstream. And we have lots of people who have lots of different ideas. And some people still subscribe to relativity. Some subscribe to other things we had on the list, but here's the nick of time. So if you want to take a look at, there's some unipolar induction, resolving paradox. There's Bill Lucas, another person that's has come on to our channel and is also a Lifetime Achievement Award person. But you can see all these videos, and look, the subscribers are going up. Nick has a lot of good videos himself, but those are available. And well, the good news is we will have, the good news is when we move this to StreamYard, it will not only be live where you can interact with them, just like we do, but you also have it available immediately on the CMPS channel. And so that'll be great. And look forward to Ian and Franklin and other people. You'll see more people here in the green room, because we can actually put them all up here. I mean, I'll show you. There's one person, there's one person, there's one person. See, we can put them all up there. And so we do plan on doing that. And I put people on without their permission, but I did it really quick. But I want to thank everybody here. Please keep coming back. And if you are a person that wants to come back and explain to me what you've done, even your work, even if I'm a person who doesn't agree with something that it concludes, let people make their own decision. That's the way I say. I say never believe anything. Don't believe me that the neutrino's a terrible idea. Go and look at it for yourself. Look at Dr. Karazani's work. He's the premier person. I didn't come up with this. I read his work. If you, again, anything that we talk about here is allows people to give their opinions about it, and you should not make your decisions by what we say here. So let's get going, and we'll close this out for today. Remember what I always say, stay critical, stay thinking. I'm Dave D. Hilster, your science therapist, trying to get to the promised land of becoming a critical thinker. Ciao for now.